Hi geometry students, welcome to the lesson for 8.1, and these are our vocabulary terms for this lesson. We're going to talk about ratios and proportions for the majority of this lesson today. So let's get right into it. Ratios and proportions. So ratio and proportion is the title of the lesson. If A and B are two quantities with the same units, and that's very important. They have to have the same units. We're defining a certain word here. So then the ratio. So if they have the same units, then you can define a ratio. This is the definition of ratio. Ratio of A to B is, you can write it in two ways. A over B, you can write it as a fraction, A divided by B, or equivalently, you may see it in this form as well. A and then a colon and then B. So if A was 5 and B was 6, you'd have a ratio of 5 over 6 or 5 to 6, like that. And so let's check out some conversions as well. You'll need to know these conversions for sure to be able to do ratios. You have to convert things to the same units sometimes. Sometimes they're not in the same units. These are some things you're going to have memorized. Most of them you should have down already by this point in your mathematics careers, but in case you didn't, you got to learn these right now. So a meter is 100 centimeters. 1 centimeter, you look at the itty-bitty marks, there's 10 of those, 10 millimeters per centimeter. If you think about this, if there's 1 meter per 100 centimeters and 1 centimeter per 10 millimeters, that means there's 1,000, 10 times 100 millimeters in 1 meter. So you could also say that. You should also know this. This should be common knowledge at this point for everyone, but 12, there we go. 1 foot is 12 inches. 1 yard is 3 feet, meaning that 1 yard is 36 inches. You multiply 3 times 12. That's another one you can derive from that. 1 pound, LB is the abbreviation for pound. 1 pound is 16 ounces. 1 kilogram, if you ever see that prefix kilo, you should think 1,000. So 1,000 grams is equal to 1 kilogram. This isn't here, but you should know also that a kilometer or kilometer is 1,000 meters, but that prefix kilo always goes together with that. And then probably the most obscure one, but you have to know this one too, 1 mile is 5,280 feet. This is part of the reason why I like the metric system so much more than the English standard measurement system from what we have in the US. This doesn't make any sense. Where did this number come from? I don't know. So multiples of 10 makes a whole lot more sense. But let's check out an example now where we're going to find some ratios. So part A, part B. We'll have two parts to this, but the instructions for both will be to simplify the ratios. And so a ratio, from our definition, it has to have two quantities with the same units. So we're going to be given a fraction. First we're going to see if it has the same units. 12 inches over 9 inches. Let's start with that. Does this have the same units from here to here? Sure it does. And so we can basically get rid of the units. Let's do that. Let's cross that out. Okay, so the inches is gone. Now we're just comparing the numbers. So 12 over 9, you can reduce that. Divide by 3, you have 4 over 3. You can write it like that, or you can write it like this, 4 to 3. So you'll see that or that. Either way is going to be okay when you're talking ratios. And then another one, 100 centimeters compared to 2 meters. Now back to the definition of ratio. They have to have the same units. If they don't have the same units, we're going to have to use these conversions. And so here, 1 meter is 100 centimeters. We can utilize that here. So 2 meters would be, hopefully clearly, 200 centimeters. If 1 is 100, 2 is 200. So this would be now giving me the same units. I could have changed centimeters to meters as well, because I know there's 1 meter in each 100 centimeters. So I could have written this as 1 meter over 2 meters. That would be equivalent to what I've said here. So a couple different ways to do that. Now that you have the same units, though, they can go away. You've got 100 divided by 200. If you have the same number of zeros, you can cross them out kind of one at a time, and what you're left with is your answer here. 1/2 or 1:2. You can write it either way. So a 1:2 ratio if this is the fractions you started out with. 4:3 ratio for this one, 1:2 ratio for that one. So be careful. Make sure the units are the same with these kinds of problems. If they're the same, then you can just simplify the fraction that's there. But if they're not, you're going to have to convert it first and then do that. All right, example 2. Example 2 we've got here is situation and the given stuff. So the perimeter of, this is going to be rectangle. So the perimeter of rectangle Carl, use capital letters for our points there. Carl is 36 centimeters. And this is going to be C, A, R, and L. When you're drawing this, I want you to draw AR and CL a little bit longer than RL and AC. This is going to be slightly longer than this. How much longer, maybe you ask? Well, here we go. The ratio of CA, notice I'm not putting segment marks above it. I'm saying CA, this is the distance from C to A. It's just a number. The ratio of CA to AR is 4:5. So if we think about that in terms of the picture, here is CA. That's 4 compared to AR is 5. But it's not necessarily 4 units and 5 units. It's whatever this is going to be 4 compared to whatever this is going to be 5 in that ratio. They're going to be proportional to each other in that way. So maybe this is 8 and this is 10. If you simplify 8 over 10, you get 4/5. Maybe this is 12 and this is 15. You simplify that, you get 4/5. So we're going to find out what it actually is based on this and based on the ratio. So what we're going to try to do here is find the length and width, sorry, not of, but and width of the rectangle. And then this one I'll put S-O-L-N, sorry, S-O-L-N for solution, and write some things here to describe why the answer is what it is. So write this stuff down for me. Since the ratio is 4:5, and if you ever have a problem like this, you can say this sort of thing. We can say that since they're in that ratio, we can just basically put x's after the numbers. We can say that CA equals 4x and AR equals 5x. So if that's true, let's put that in the picture. Let's put that in the picture, and let's get out a different color at this point. So pause if you need to, get out that different color, and let's underline this in a different color and put that in the picture up here. So I know that CA is going to be 4x. Since this is a rectangle, this would also be 4x over here. And since AR is 5x and it's a rectangle, opposite sides congruent in a rectangle, that's also going to be 5x. So we've got that. So what can we say? Well, I know the perimeter is 36, and I know that these are related in the way drawn here or shown there. So we have that this is going to be true. That 2, you know the perimeter of any rectangle is 2 times the length plus 2 times the width. You just add up all the sides. So you can think of it like that. You could write it like that even if you wanted to. 2L plus 2W equals 36. But if you want to just add up the sides, you can do that too. So I'm going to put that right here. It's just the sum of all the sides. So 4x plus 5x plus 4x plus 5x is going to equal 36. This is the perimeter. And one more thing we'll do in the different color. I want you to underline that and draw an arrow to there. So that's where that number came from. 36 is the perimeter. The perimeter, you add up all the sides. So let's combine like terms here. We're going to have 9x plus 9 more x will make 18x. Divide both sides by 18 and you have x equals 2. And so that doesn't tell you what your length and width are yet, but we're real close now. So we know that x equals 2. So the length is going to be 2 times 5, and the width is going to be 2 times 4. So we're going to have 10, and this, it says it is in centimeters, so we want to include that too. So this is 10 centimeters. That came from 2 times 5, and just separating that from that over there, and the width is going to be 8 centimeters, which came from 2 times 4, 4x and 5x. So maybe the better way to write that, let's do that here. Let's write it as 5 times 2 and 4 times 2, just so that makes more sense later when we look at it. So 5 times 2, that's 5 times x, and this was 4 times 2, 4 times x. That's our final answer. Let's box that in. Alright, so that's how we're going to do a problem like this. Think it through rationally, logically, and that should make sense from there. Now, we talked about ratios here. Now we're going to talk about something called extended ratios. We're going to extend the idea here. And here is the problem. So we have a triangle, and here's what we got on this one. The measures of triangle boy. We're going to call this triangle boy. This is going to be B right here. Down here is going to be O, and here is going to be Y. So the measures of triangle boy, I should say the angle measures. Let me put that in there. So insert that in there. The angle measures of triangle boy are in the extended ratio, and that's a new term for us. So let's underline that. Extended ratio 1 to 2 to 5. So you might wonder what the heck is going on there. Just a moment, we'll get there. So what are their measures? Looks like arc, there we go. What are their measures? So since these are the extended ratios, let's get out that different color again. It's saying that it goes in this order. So B to O to Y is going to match up with 1, 2, and 5. So B matches up with 1, O matches up with 2, and Y matches up with 5. It's not saying that this is 1 degree and that this is 2 degrees and this is 5 degrees. It's saying that whatever this is going to be in this 1 to 2 to 5 ratio. The angles are going to be in that ratio. So we could call this 1x, or x degrees. So let's do that here. This is going to be x, and this is going to be, I'll say x degrees. This is going to be 2x degrees, and this is going to be 5x degrees. If they were in the extended ratio of, let's say, 2 to 6 to 9, you would put 2 here, a 6 here, and a 9 here instead. If they were in a ratio of 3 to 4 to 5, this would be 3, 4, and 5. Whatever the order of the letters is and the order of the numbers is, that's how the ratios should match up. So let's put our solution down here, our thought process. Down here we can let, so where did this come from? Let's write this down as a reminder when you look at your notes later. We can let the measures of the angles be x, 2x, and 5x. Again, that's coming from the 1 is just the plain old x, the 2 is the 2x, the 5 is the 5x. And seeing that that's true, then we can say, well, the angles in a triangle are supposed to add up to 180. So we add these three things, we should get 180. And so we can say that x plus 2x plus 5x equals 180. Meaning, combine like terms, you have 8x equals 180. If you divide 180 by 8, you don't get a nice whole number, but you do get a pretty easy to deal with decimal. It's going to be 22.5. 5. So now our final answer. What are their measures? We just plug this back in now. So the measure of x, or the value for x is 22.5. Plug that back in into each one of these up here in the picture. So the measure of angle B, don't forget your little m in front of the B. The measure of angle B is 22.5. It's just x. And the measure of angle O is going to be that times 2, which is 45 degrees. That's just 2 times 22.5. And finally, the measure of angle Y, that is 5 times 22.5, ends up being 112.5 degrees. So that's where this comes from, right there, 5 times 22.5. So we'll box that in. There we go, that's better. And so that is my final answer for that one. And we've got one more concept I want to hit here about, we've done all this ratio stuff. Now what are proportions? Maybe you remember that from algebra, maybe not. This last page we're going to do some stuff with proportions. So a proportion is an equation that, and this sounds kind of fancy, but it just means sets them equal to each other. It's an equation that equates two ratios. A ratio is a fraction with the same units, and so it equates two fractions. And so we are going to write under here, here's an example of a proportion with just letters instead of numbers. So A over B equals C over D. That's an example of a proportion. One fraction equals another fraction. Same units here and same units here. This one we don't have units given to us, so we're assuming that they are the same. And so one other thing I want you to do here, in a different color, I want you to circle A and D, and I want you to circle B and C. Those are going to go together. So A and D are going to go together here, and then B and C, we'll put those two things together over here. So these are kind of the extreme parts of the fraction, the very beginning and the very end. If you read this proportion kind of like a book almost, left to right, up to down, you're going to have A be the beginning and D be the end, at the extreme ends of the fractions. That helps me remember why we call these the extremes. These are the extreme parts of the fractions. And then the means, if you hear the word mean, you kind of think, well, you might think angry or upset or just mean, yeah. But if you think that in math, we're kind of thinking of things in a kind of a middle sense. So mean, middle, they're going together here. These are called the means. The means. So the means, they go in the middle, and the extremes are on the extreme parts, on the very beginning, very end of the fractions, if you read it like a book. And so let's check out a couple of final examples where we solve proportions. That is the instructions here. Solve the proportions. So there's going to be two parts to this. We're going to have part A here, part B here. And this should look very familiar from algebra. So let's see if we can do that. Solve for y there, and let's see if we can do this a little trickier over here. But 4 over, sorry, that's supposed to be a 2z, 4 over 2z plus 6 equals 10 over 7z minus 2. Alright, so let's solve these proportions. How do we do that? How can we solve proportions? Hopefully you remember something called cross multiplication. And so the book, I'm not going to write this down and define it formally, but the book talks about these two properties, the cross product property and the reciprocal property. You can say that the cross product property is basically cross multiplication. A lot of us think of it like that. So in your different color, over the equal sign, I want you to make an X. That's going to remind us to, or tell us to, cross multiply these things, the cross product property. You can also say by the reciprocal property that if y over 8 equals 9 over 10, you can flip them around and say that 8 over y equals 10 over 9. We don't need to use that here, but that could come in handy later on. So let's see what we got here. 10 times y would go on one side, 10y, and then 9 times 8 would go on the other side. That would be 72. And so if you want to write that intermediate step in there, 10 times y equals 9 times 8, and go to there, that's fine. But I hope most of us are okay with this. Seeing that you passed algebra, we should have done that at some point in our lives before. And so we get to this point, we're going to divide by 10 to get rid of the 10 in front of the variable. So divide by 10, you've got y, and then this doesn't work out to be real nice, but you could, if I said to leave it as a fraction, you'd want to simplify that. You could divide by 2 and get 36 over 5. Why don't we write it down as 72 over 10 first, though? So we could have that. That would be the same thing as 36 over 5. You could also say, if I was allowing you to write it as a decimal, you could say 7.2 as well. So this is what y would equal. And it kind of just depends on the situation. That here it might make more sense to say 7.2 than 36/5, because you're making a comparison of 7.2 to 8. That seems legit. That fraction would be the same as 9 over 10. And let's do one more here. And let's do the same thing, cross multiply. But when you do this one, I want you to draw this in a different color too. Draw in, these are kind of like invisible parentheses here. So I want you to think of everything being in parentheses. Let's put this in parentheses too, to really emphasize that point here. So think of invisible parentheses around the parts of a fraction. If you do that, you won't get in trouble by forgetting to distribute. And so what do we have here? I have 10 times 2z plus 6. And then on the other side I have 4 times 7z minus 2. You'll notice I removed the parentheses from the 4 and the 10, but I didn't do that with the stuff on the bottoms of the denominators, because I'm going to need to distribute that through. So in your different color, let's get that out one more time here. Let's show that. So we're going to distribute the 10, we're going to distribute the 4. From there, let's solve this. We've got 20z plus 60 equals 28z, and that's supposed to be a minus sign. That looks a little funky there. There we go. I think that's better. So that 4 times negative 2 is going to be negative 8. I like to keep my variables positive, so I see that this one's bigger than this one coefficient wise. So I'm going to subtract 20z. And since I moved all my z's to the right, I'm going to move my regular numbers to the left. That's gone there, and I'll add 8 and add 8. So I'll do that in the same step here. This will give me 68 equals 8z. And this one, I can divide to finish it, divide by 8. I'm going to get z equals, it's okay to have the variable on this side instead of this side, that's fine. I could say it's 68 over 8. I could reduce that though. If I had to leave it as an improper fraction, let's see what that would be. So divide by 2. You could even divide by 4 actually. So this one divided by 4, let's see, that'd be 17 over 2. So that's one way to write it. Another way you could write it would be, that would be 16 divided by 2 would be 8. So 17 divided by 2 would be 8.5. You could also write these as mixed numbers. I'm going to leave that out here, but you could say this one is 7 1/5, and this one you could say is 8 1/2 as well. So plug that back in, you can check your answer. I'm not going to do that right now on the video, but good idea to do that. I'll just do that. I won't write it out, but I'll do it at least mentally here. So 2 times 8.5, 17. 17 plus 6 would be 23, so 4 over 23. And then 8.5 times 7, let's see what that would be. So 8.5 times 7, that would be, 8 times 7 is 56. So another 3.5 to that, 59.5. And then we'll have 57.5, 10 over 57.5, and then 4 over 23. That seems reasonable to me. You could check that with the calculator as well to see that those fractions equaled each other. But from there, I have nothing else for this lesson. Let me know in class if you have any questions, and we'll definitely be practicing some more proportions and ratios in class. All right, have a good one, guys.